Hello friends, today I am going to start a complete course on material characterization. In this video, I am going to explaining some basic material characterization like introduction to material characterization, nanomaterial, properties of nanomaterial, types of nanomaterial, applications of nanomaterials. So first of all, if you consider the material characterization, material characterization is a crucial aspect of scientific research, engineering and manufacturing process. By studying and understanding the properties, composition and behavior of material, we gain valuable insights that help us to make informed decision and drive innovation across various industries. Material characterization is generally used in material science and it refers as a process by which a material structure and properties are identified and measured. It is very important to know the material structure, characteristics and properties because in manufacturing we need to know the mechanical, the thermal, the electrical properties and the structure of the materials. After this material characterization, there are a number of aspects of this material characterization. That is, identifying material properties. This includes mechanical, electrical, thermal, optical, and chemical properties. Understanding material structure. This involves analyzing the arrangement of atoms, molecules, and larger structural features within the material. Analyzing the material behavior. This includes studying how material respond to different conditions like temperature, pressure and stress. So common characterization techniques and instruments, just to know the structure of the materials. So we need a materials or the tools like the spectroscope or microscope techniques. So the spectroscopic techniques, what it consists of means like X-ray diffraction, that is which can determine the crystal structure and the lattice structure or the internal structure of a material. Inductively coupled plasma mass spectrometer, so that analyzes the elemental composition. Next, UV spectrometer measures absorption and transmission of light, providing information about electronic structure and composition. Raman spectroscopy identifies material composition and structure based on vibrational modes. X-ray photoelectron spectroscopy investigates the chemical composition and electronic state of material surface. So after knowing all this, so next our topic is that is nanomaterial. Nanomaterials are the basic historical background of the nanomaterials we can consider is that is most first of all that nanomaterials we cannot see through our naked eye. Nanomaterials were firstly used in 9th century for generating glitters effects on the surface of part. Richard Simon first observed and measured the size of nanomaterials. He also used the term nanometer for characterizing the particle size. So this nanoscience, which deals with building up of complex material and machine using fine control on the matter at the nanometer scale. Study of material and their properties at the length scale of few nanometer is called nanoscience. To study the nanomaterial, we need tools and techniques that will be used for preparing the nanomaterial for the characterization of the nanomaterial. and using the properties of the nanomaterial in different application. These tools and techniques in the preparation of nanomaterial, characterization and use of the properties of nanomaterial in different applications are called nanoscience. After knowing what is meant by this nanomaterial, let us see the properties of a nanomaterial. So it is observed that when the material size are reduced to the nanoscale, they show different properties as shown in bulk material level or in the macro level. At the nanoscale, the number of properties will going to like optical property may change, thermal property may change, electrical property may change, and the mechanical property also may change. So one of the important reason why the property change when the materials are reduced to nanoscale is surface area to volume ratio. Now, surface area to volume ratio will increases when size of the material will decreasing. So when you decrease the material size, then the surface area and volume ratio will increases. So let us see the first property, how the optical property will going to changing when the bulk material is reduced to nanomaterials. First optical property, that is when light is incident on the material, it can be absorbed or scattered. If the size of the material is less than 20 nanometer, absorption is significant, and if the size is greater than 100 nanometer, scattering is significant. Thus, by designing the nanoparticles of different sizes, optimal amount of absorption or scattering can be achieved. Example, opaque substance at the bulk level become transparent at nano level, like for copper. Next, for example, gold. Nanosphere of 50 nanometer of gold, which looks like a color green, and if the size is at 100 nanometer, then the gold will appear in orange color. So in the bulk size, it looks like a color that is yellow. So the size is also a matter, that the size and volume also matter for the nanoparticles. Next, that is electrical property. The electrical property of a material, electrical conductivity of a material is altered when it is reduced to nano size. It is possible to invent nanomaterials having deserved conductivity. Example, in ceramics, the electrical conductivity increases with the decrease in nanoparticle size. In metals, electrical conductivity decreases with increase in nanoparticle size. Next, there is a change in magnetic property. So next is, that is magnetic property. Nanomaterials are more magnetic than the bulk material. Even non-magnetic solids are found to show magnetic properties when reduced to nano level. Magnetic properties of the material can change when reduced to nano level. Example, sodium, potassium, which are paramagnetic at the bulk level, become a ferromagnetic at the nano level. Next example, you can also take iron, cobalt, nickel, etc., which are ferromagnetic at the bulk level, become super paramagnetic at the nano level. So this is which indicates that, so if you reduce the size of the bulk material to nanomaterial, the magnetic property will changes. Next property, that is structural properties. In nanomaterial, surface area to volume ratio is very large. Atoms on the surface of a material are often more reactive than those in the center. So, a larger surface area means the material is more reactive. Force of attraction between surface can appear to be weak on a larger scale, but on a nano scale they are strong. This may lead to different surface morphology, changes in crystal structure, etc. The surface of a dendrimer has numerous chain ends which can perform specific chemical functions. Dendrimers are used in molecular recognition, nanosensing, light harvesting, and optoelectrochemical devices. They may be useful for drug delivery. So this is the structural properties of a material. So after this, so next is the mechanical property. So mechanical property of a material, if you consider the mechanical properties like hardness, elasticity, adhesion, friction improves as the material size is decreased to nanoscale. Lubrication improves at the nanoscale. Ductility of nanomaterial may be high at high temperature. So these are all the properties of a nanomaterials. Next, let us see the types of nanomaterial. So the types or the classification of a nanomaterial, we can classify it into two parts: naturally occurring nanomaterials and man-made nanomaterials. Naturally occurring nanomaterial, for example, forest fires, viruses, sea spray, proteins, volcanoes, they are all naturally occurring nanomaterials. Man-made nanomaterials, we are usually classified into two types: incidental nanomaterial and engineering nanomaterial. If you consider the incidental nanomaterial, which consists of cooking smoke, industrial effluent, welding fumes, so they are all incidental nanomaterial. Next, engineering dot metal oxide, so which are all considered under the engineering man-made nanomaterial. Depending upon the nature, they are classified as the organic, inorganic, and carbon-based nanomaterial. Depending upon size and dimension, they are classified as 0 dimension, 1 dimension, and 2 dimension. Next, the 3 dimension nanomaterial. So if you consider the organic nanomaterial, so that organic nanomaterial, these nanomaterials are biodegradable, non-toxic. So it is widely used in biomedical field. Example for organic nanomaterials are dendrimers. So dendrimers are repeatedly branched molecules. The names come from the Greek word dendron, that is tree. These nanomaterials are nano-sized polymers built from branched units. So this dendrimers surface has a numerous chain ends which can perform specific chemical functions. Dendrimers are used in molecular recognition, nanosensing, light harvesting, and up to electrochemical devices. They may be useful for drug delivery. So next, if you consider an inorganic nanoparticles, metal and metal oxide based nanomaterial. So next, that is metal-based nanomaterial. If you consider nanoparticle that are synthesized from metal or metal-based nanoparticle, almost all the metals can be synthesized into their nanoparticles. The commonly used metals for nanoparticle synthesizers are aluminium, cadmium, cobalt, copper, gold, etc. So metal oxide based nanoparticle, if you consider, the metal oxide based nanoparticles are synthesized to modify the properties of their respective metal based nanomaterials. Nanoparticles of hydrogen instantly oxidizes to iron oxide in the presence of oxygen at the room temperature that increases its reactivity compared to iron nanoparticles. Metal oxide nanoparticles are synthesized namely due to their increased reactivity and efficiency. The commonly synthesized are aluminum oxide, selenium oxide, iron oxide, magnetite, silicon dioxide, zinc oxide, etc. So these are all the what we are considering, that is the metal based nanomaterials, which are we can consider this as a inorganic nanoparticles. Next, if you consider, so that is the carbon based nanoparticle. There are variety of carbon based nanoparticles. So carbon based nanoparticles, these are which have a lot of application in various fields. The nanoparticles which are made completely of carbon are known as carbon-based nanoparticles. Like first, that is I am considering fullerenes. So fullerene, which consists of 60 minimum 60 carbon atom that shaped spherical in shape, 20 hexagonal, 12 pentagonal faces, which looks like a Shuki ball. So Shuki ball, so this is the carbon tube. So this fullerenes, so it is you can take as, so that is the fullerenes. So next is, that is carbon nanotubes. So carbon nanotubes are cylindrical of one or more layers of graphene wound into hollow cylinder for nanotubes of diameter as low as 0.7 nanometer for a single layered and 100 nanometer for multi-layered carbon nanotubes, and length varying from few micrometer to several nanometers. Thermal and electrical conductivity are also high compared to other material. Carbon nanometer shows a unique characteristics, stiffness, strength, and compared to other fiber materials. So after this, I am considering this, that is the applications of nanomaterials. So applications of nanomaterials, there are in variety of various fields. So it has a wide application. So like first one I am considering, that is the medicine. So in the medical field, that is for the drug delivery, nanomaterial can be used to encapsulate and deliver drugs to targeted areas in the body, improving efficiency and reducing side effects. Diagnostic nanomaterial can be incorporated into medical imaging and diagnostic tools, enhancing sensitivity and accuracy. Tissue engineering. So that is nanomaterials can serve as a scaffold for tissue regeneration and repair, offering promising solution for damaged or diseased tissues. Electronics improved efficiency. Nanoscale components are used in electronic devices to enhance efficiency and functionality. So this are next after this, if you consider the third one, that is energy. So like solar energy, fuel cells and insulation, in all this field we are using this nano materials. And the last, that is environmental sciences. So we can use this nanomaterial for water purification, for catalysis in various industrial process, making them to more efficient and environmentally friendly. For soil remediation, can be used to clean up the contaminated soil, restoring soil health. And the last, that is textiles. So in the textile, nanomaterials are properties of fabrics, making them self-cleaning, water repellent or antibacterial. So next, in the food industry, nanomaterials are used in food packaging, storage and processing, potentially enhancing food safety and shelf life. So thank you for watching. So this is our first video. So thank you very much.